Hello, this lesson will cover scientific notation. Now in chemistry and a lot of other sciences we use very large and very small numbers. To efficiently write these really big and really small numbers we use a format called scientific notation. A good example in chemistry is Avogadro's number. This big huge number here. 6022 with all those zeros. That is a number that we'll use quite a bit in chemistry, and we'll do calculations using that number. Now that giant number will be a pain in the butt to put in your calculator, and in fact some calculators you can't even put that in there because they'll just hit the end of the screen and it won't let you put any more zeros in. So we will use a format called scientific notation. So that number, this giant number here, is the same as this number. They're just written in different formats. They're the same number written in different formats. This one is written in scientific notation. Basically, it's a way of getting rid of all those zeros. All these zeros at the end. It's a way to write it without those zeros. And I'll show you how to do that. Some basic rules here for scientific notation. First one is the decimal point always goes after the first non-zero number. And you'll see that in this example. Here's a 6, and right after the first non-zero number, right after that first number, is the decimal point. Decimal point always has to go right after that first number. Scientific notation always contains times 10 to some power, in this case times 10 to the 23. Now that exponent, the 23 in this case, is a positive exponent because this number is a really big number. It's greater than 1. So numbers, greater than 10. Numbers greater or equal to 10 get a positive exponent. If this is a really small number, it would get a negative exponent. So again, numbers less than 1 get a negative exponent. Numbers 10 or greater get a positive exponent. And last rule is the exponent is the number of places you moved the decimal point. Some people get confused and they say, oh, the 23 comes from there's 23 zeros. There's actually there's less than 23 zeros. It's how many decimal places it moved from the end here to after the 6, where it ends up here, after the 6. It moved 23 places. So, do a couple examples here. We have 293 million. So, 293, 0, 0, 0, 0, 0, 0. 293 million. Now, I'm going to write that in scientific notation. First thing I'm going to do is I'm going to write the non-zero numbers there. The 2, the 9, the 3. Those are our sig figs. And the second thing I'm going to do is I'm going to put that decimal point right after that first number. So 2.93. And I know it's always times 10 to the something. Now if I look at my original number, this is a really big number. This is greater than 10. If I had $293 million, that would be a very positive thing in my life, and therefore it would be a positive exponent. Remember, big numbers get positive exponent. So all I do is I count how many decimal places to get the actual number for the exponent. I count the decimal places. So the decimal point is right here. I want it to be after the 2, as we can see here in scientific notation, always after that first number. That 9 looks a little weird, but go with it. So I count the number of decimal places. 1, 2, 3, 4, 5, 6, 7, 8. So my exponent is 8. So writing that number in scientific notation is 2.93 times 10 to the 8. Next example. Okay. Again, scientific notation. just gets rid of all these zeros. And let's see, I got 4 more zeros there. So all these zeros we're gonna get rid of those when we write scientific notation. My sig figs are the 3, the 4, and the 5. So I have to write those. 3, 4, 5. And I know the rule says decimal point after the first number, so there we go. You know, the rule says it's always times 10 to the something. And this number, you know, if I had this much money, it wouldn't be that big a deal. So it's a very, very small number. And small numbers, numbers that are less than 1, get negative exponents. So I know the exponent here is going to be negative something. I just got to figure out what that something is. Here is the decimal point, and I want it to be after the 3. I count the places, the number of decimal places between where it starts to where I want it, and that gives me my exponent. So 1, 2, 3, 4, 5. 3.45 times 10 to the negative 5 is this number in scientific notation. 3.45 times 10 to the negative 5. So why don't you try a couple here. If you want to pause a little video, and you can do these on a piece of scratch paper, or if you printed out the notes, you can do them right there in the notes. Write those in scientific notation. Pause the video, do that, and then when you're ready, hit play again, and we can check our answers. So, this next example, 4, 3, 0, 0. My sig figs are the 4 and the 3, so I'm going to write those. I'm going to put the decimal point after the first number. I'm going to put the times 10. And this is a big number. So it's greater than 10, so it's a positive exponent. And I'm going to move it 1, 2, 3 places, because the decimal point is right here. I didn't write it, but I know it's there. And I want it after the 4. So I count how many places? 1, 2, 3. So my exponent is 3. So 4.3 times 10 to the 3 is your answer for that example. Next example, 0.00324. Again, the 3, the 2, the 4, those are our sig figs. And decimal point always goes after the first sig fig. It's always going to be times 10 to the something. And in this case, small number. So, negative exponent. And I count how many places. I want it after the 3. It's right here. And I count how many places it takes to get there. 1, 2, 3. There we go. 3.24 times 10 to the negative 3 is your correct answer. Okay. Calculations with scientific notation. It's very important you know how to enter numbers into your calculator in scientific notation. Every calculator is different, so see me if you aren't sure how your calculator works. So if you don't know how to put this number into your calculator, be sure and see me and I can show you how. So, a couple tricks. For calculating with, or doing calculations with scientific notation. The tricks are for multiplication and division. So, the example here. Multiplication. What you do, the trick is, if you have a really simple calculator, like a little calculator I have here on the side here, it doesn't have exponent buttons. I can't do exponents. I can't do scientific notation with this calculator. But, if you know this trick, you'll be able to do this type of math with a simple calculator. And what you do is you multiply the numbers in front. So I do 8.0 times 4.5. And that gives me 36. So, and I know it's going to be times 10. And to figure out what the exponent is I just add the exponents. 23 plus 5 is 28. And the way I remember that is multiplication sign, if you gave that a twist, kind of looks like a plus sign. So whenever you multiply scientific numbers together, you add the exponents. Now there's one problem with this answer, and maybe you've noticed it already. Where is the decimal point here? Well, the decimal point is right here. It's after the 6. It's not written there, but we all know it's there. And one of the rules is, for scientific notation, the decimal point has to be after the first number. So what we're going to do is we're going to move it one more place over. But when we do that, that's going to affect the exponent. Now, 36 times 10 to the 28, that's a really big number. Positive exponent, big number. So I moved it one more place, so that's going to increase the exponent by one more. So my final answer is 3.6 times 10 to the 29th. Now, if you have a calculator that you can do exponents on, this is the answer it would give you. But just in case, I want to show you this trick. Multiply the numbers in front, add the exponents. Rule is fairly similar for division. You do the numbers in front, so 9.6 divided by 3.0 gives us 3.2. And since it's scientific notation, I know that it's going to be times 10 to the something. Now for division, I subtract the exponents. Top minus bottom. So 12 minus 8. 12 minus 8 is 4. So, the way I remember that, division symbol kind of looks like this. Well, imagine it without the dots. It's a minus sign. So when you divide scientific notation numbers, you subtract the exponents. Again, if you had a graphing calculator or a scientific calculator that you can do exponents, you would simply just type this in, and if you aren't sure how to type this in, I can show you how to do it. You type it in, hit enter, and it will give you the answer, 3.2 times 10 to the 4. But in case you have a simple calculator, like the one I have here, this is a little trick to help you get the correct answer. So that is it for scientific notation.